So welcome everybody. So today I'm going to be talking to you about the background on background tasks in .NET 6. So I've already posted these slides up on my blog. It's just my first and last name, scottsauber.com. And if you want, you can follow me on Twitter. It's just Scott Sauber there as well. Tweet about .NET and sometimes barbecue. All right, so just a level set real quick on who I had in mind when I created this talk. Hopefully this is a safe bet for the Chicago .NET user group, but I'm targeting .NET developers in need of run some sort of operation in the background where you don't want to do like that synchronous request response. Maybe you want to do some processing in the background. So we're going to talk about all this stuff today. We're going to talk about what are background tasks or jobs, just to kind of level set real quick. I'm going to talk about what types of problems are suited for such a thing. We're going to talk about all these different options that are out there, such as iHosted service, background service, worker service, and Hangfire. I'll also briefly touch on cloud options, but I'm going to focus on those four that I listed just because they're cross cloud and you can run them on-prem and all that kind of stuff. Like they're, I shouldn't say cross cloud, they're more cloud agnostic. It doesn't matter where you host those. So with those four options, we'll talk about why you would choose one over the other, and I'll do a deep dive into each of those, do some live demos. And if you have any questions, I'll try and watch the chat, or if you want to just unmute and start talking, that's perfectly fine too. And I'll try and pause after we talk about each one of these so you can jump in with some questions or wait till the end. Basically, anytime you want to ask a question, just go ahead and fire away. So the goal out of this talk is for you to know all the different options out there for running background tasks, and more importantly, why you would choose one over the other, because there's just lots of different options and sometimes it's not super clear why you would pick one over the other. So as David alluded to, here's my bio slide. We'll spend the next 45 minutes talking about this. Just kidding. But I'm the director of engineering at a software consulting company called Lean Techniques. We're based in Des Moines, Iowa. We have roughly 100 people. I'd say 80% are in Iowa, and then the remainder are scattered across the US. We don't have anybody from Illinois, and we are hiring. So if you're interested, just reach out to me afterwards and maybe we can get connected. Most of the co-organizer of the Iowa .NET user group. I'm a friend of Roygate, and I blog as well. All right, let's start diving in. So just a level set real quick on what problem background tasks solve. There's really lots of different scenarios where you want a background task. So let's say you want to pop some messages off of a queue every minute or so. That would be one example where you'd want to do like some cron job operation. Another cron job operation would be, let's say, when you sign up for a credit card, you can set up notifications to say, hey, when I'm 7 days out, go ahead and send me an email reminding me that my payment's due or something to that effect, right? So that would be another example of a cron job. And the example that we're going to go over in the demo, where we kind of see these side by side in the exact same scenario, so you can kind of get an idea of how they look in different ways, is refreshing a cache every so often. So let's say every 5 minutes, you're going to query a database and refresh a cache. That would be another example in a use case for a cron job. And there's obviously millions of other use cases for cron jobs, but those are just some ideas. As well as if you need to perform some CPU intensive work, asynchronously being the key there. So let's say, you've got a create invoices button or send invoices button. And as part of that, you need to generate, 1 million PDFs because you need to email out these PDFs to all of your customers. You probably don't want to do that in a synchronous, without the A, synchronous fashion, where you click the button and then generate all those million PDFs and fire off the emails. Like, you probably want to do that asynchronously. So that would be an example of, you'd probably want some sort of background task running. So that way you offload some of that work and you're not doing that synchronously. So that concept is called eventual consistency, where eventually you're consistent. Usually you use that with more like databases, where when you click the save button, you don't save immediately, you save eventually. But that would be another example of where you'd use a background task. And I don't really know anything about ML or AI other than I know what they stand for, but supposedly retraining machine learning data sets is also pretty CPU intensive. So that's probably something you want to do in the background as well. All right. So Now that we kind of level set it on what a background task would be used for, let's talk about some of these options. So let's just go ahead and dive right in. I'm going to use the analogy of baking cookies on each one of these options. So if you can kind of think of a spectrum of baking cookies, like let's say you're like, okay, I want to eat some cookies, right? On one end of the spectrum, you have like, hey, I just have the raw ingredients, but I don't have like a recipe. I don't have a cookie jar to put them in. I don't have any of that. I got to figure out what I want to do for all those options. Like that's one end of the spectrum where you have a lot of control and you get to choose how you make your cookies. On the other end of the spectrum is going to a grocery store and going and buying like Chips Ahoy or some cookies off the shelf where it's all already pre-packaged for you. They've picked the ingredients, created the recipe, baked them. Everything's kind of all bundled up. So that's the analogy I'm going to use here when we're talking about all these different options. So we're going to start with like the more raw option where you get full control and go all the way up to like where you're buying these prepackaged cookies off the shelf. So to start off with that analogy, we're going to talk about I-hosted service. And this is kind of the make your own recipe where you've got the raw ingredients, but it's up to you how you want to combine these ingredients together. And the cookie jar is included. And I'll talk about that here right now. So an I-hosted service lets you host a background job inside of an ASP.NET Core app. And I'll talk a little bit later about how that's not always the case when you're talking about an I-hosted service, but typically if somebody's saying they're running an I-hosted service, they're talking about hosting it in an ASP.NET Core app. Otherwise, they'd use the term worker service. And we'll talk about that here in a little bit. But the ASP.NET Core app is your cookie jar. So that's where you're hosting that I-hosted service, that background job. As you might guess from the name I-hosted service, it's simply an interface and it's got a start async and stop async method. And we'll take a look at that here in a second. And an important part of I-hosted service is it's like a raw fundamental building block for a lot of these options that we'll talk about later. So it's pretty simple. You just register it through dependency injection using services.add-hosted-service of T, where T is the thing that implements the I-hosted service. And let's go ahead and look at a live demo. So I've got 4 projects here, hosted service, background service, worker service, and Hangfire, and 5 projects, and then a shared project that's kind of used by all of these. So if we go ahead and dive into the I-hosted service option, I'll go ahead and show you what's going on here. It's not too much going on. Line 6 here is really the key. It's what we talked about earlier, where you do the services.add-hosted-service of T, where this is the thing that implements the I-hosted service. We'll talk about that here in a second. And then this is just some common dependencies that I'm going to be using on all these projects that are consumed here. So if we go ahead and dive into that guy, the first thing you'll notice is it inherits from I-hosted service. No surprise there, or implements I-hosted service. And then we can DI things just like normal. One note here is hosted services are registered as singletons. So the dependencies you register here have to be singletons as well, because, it's kind of by definition, a singleton can't depend on like a scoped or a transient, things that change all the time. Like they have to depend on other singletons. Otherwise, they're not a singleton. So if you do need to inject in a like scope service, like a entity framework DB context or something like that, you might have done this before, where you like inject in a service provider and create a scope, which is kind of simulating creating a web request, because usually scope services are tied to web requests. I'm injecting in a logger and a cache service. I'll just look at that here real quick. There's not too much going on. Basically, what this does is it refreshes a Redis cache with random data. So I've got a Redis instance running on my local machine through Docker. It's not really the point of this talk, but basically I'm going to refresh a cache every 5 seconds. So this method actually does the refreshing of the cache and then logs some information. So if we look over here, you notice I've got the start async method that we talked about earlier. Basically, I'm just logging some information saying, hey, I'm starting, and then I'm calling this refresh cache async method. And one thing I want you to note is I'm not calling a wait here, and we'll talk about why, even though that this is an async method. Basically on line 29 here, it's saying, hey, when the application is not stopping, so as long as the application is running, go ahead and call that method we just looked at that refreshes the cache with some random data. Some error handling where I'm logging the error, and then wait every 5 seconds. And so basically what this will do is every 5 seconds, it'll just refresh the cache with some random data. And if we take a look over here, my controller, oops, I'm just grabbing that cache with the same cache key and just returning it out. So if I go ahead and launch this so you can see what's going on, I think one interesting thing to note is, sorry, to go back, here in the logs, you notice it says, I'm starting the dashboard cache refresher hosted service. It's a tongue twister. And then it says, hey, now I'm ready to serve web traffic, right? So we'll talk about why that's important later. Notice that it's starting my background hosted service before it starts my actual web server. We'll talk about why that's important here in a second. But you notice every 5 seconds, it's refreshing the cache. So if I come over here, refresh, you notice the data changed. So now if I sit here and refresh, you notice it changed again. So that's basically all this is doing in the background is refreshing this cache every 5 seconds. So that was a quick demo over iHosted service, where basically at the end of the day, it's just exposing a start async and stop async method. So again, you register with the with the services.add hosted service of T. Something to note is, so I didn't show the stop async method. Let me just show that here real quick. So the stop async method, basically I'm just logging saying, hey, I'm stopping, and then I'm clearing out my cache and then returning a completed task. So that stop async method has 5 seconds to shut down gracefully. So basically, if you call that method, you have 5 seconds to do whatever cleanup operations or whatever you want to do in that 5 seconds. However, don't rely on that getting called, because it might not get called if the app shuts down unexpectedly. So like, I know we don't really deploy to physical machines anymore, but imagine you're deployed to a physical web server and somebody just pulled the power out of the web server, right? Like that stop async method is not going to get called because it was just like abruptly shut down. So don't rely on that stop async method to get called, but it can get called, assuming the app's getting shut down gracefully, like, you know, a new deployment's coming in or whatever the case may be.
So Scott, I would a similar situation be if you're running on a virtual machine and then the operating system just crashes, right? That happens sometimes, where it just, right, another reason why that might not get called.
Absolutely. Yep. So we'll talk about, we'll do a live demo here of this in a second, but something I wanted to call out here is kind of this middle box where as you register all these iHosted services, they'll actually start in the order in which you register them. So if you do add hosted service A, B, and C, they'll run in A, B, and C order. But if start async never completes, it won't call the next hosted service. So it's waiting for that hosted service to come back. And Kestrel itself, the ASP on Core Web Server, is implemented as an iHosted service. So before, when I showed, hey, you know, it's starting my hosted service before it started the web server, that was intentional. So Kestrel itself is an iHosted service and starts last. So let's do a live demo here. So what happens if I do one of these, oops, and wait right here? What do we think is going to happen? Is non-rhetorical, if anybody's interested in. Give like 10 seconds for response, and then I'll just demo it. What do we think is going to happen when I do a wait here? All right, let's find out. So I'm going to launch my web server here, or my application here. You notice it's saying, hey, I'm starting this, and it's saying dashboard cache refreshed. And dashboard cache refreshed. And oh, maybe my web server is popping up here. Nope, site can't be reached. So the problem here is I'm in a never-ending while loop so long as the application is not stopping, right? So I'm constantly in this while loop for every 5 seconds. It's waiting for this cache to refresh. So by awaiting here, basically, if I go back to this image, I'm stuck right here. And it hasn't gotten to Kestrel, which starts over here. So it's just kind of hanging out here and never, ever actually launching my application. So that's just a big gotcha with iHosted service. And we'll talk about later how background service solves this problem. I'm going to just kill that here real quick. And let's go back to the slides. All right. So start async blocks the rest of your application from starting. So if you have some sort of blocking long running work, push it out of start don't wait for that to finish in start async. So you want to do what's on the left-hand side here, not the right-hand side, where you're not awaiting that and you're just kind of doing a fire and forget as opposed to what you're doing on the right side. Now, on the flip side, that assumes you don't want that to block the rest of your application from starting. So in my case, like I don't want that to block the rest of the application from starting. I want that to just fire off in the background and proceed on, right? But let's say you have like entity framework, database migrations, right? So you might drop that into an AI hosted service and you don't want your application to boot until those migrations have run, or some other thing. Like maybe I want to prime the cache once to make sure that the cache is primed before my application starts and then start my application, right? So just kind of depends on what you're doing, but in general, you probably don't want to do an await there and block your entire application from starting. I saw a comment come in saying, is the await time infinite? So that's more, in my case, yes, just because I'm in this endless while loop. So you can kind of assume this is like while true when the application's not going to stop, because basically that's what this is cancellation requested is saying. Is like when my application's not stopping, keep running this code. So I'm in an endless while loop, but it's more due to my code, not anything else. I saw David said coconut does not belong in cookies. I wholeheartedly agree. Side note, my favorite cookies are chocolate chip cookies without the chocolate chips, which sounds weird, but like I like the brown sugar and all that kind of stuff. But anyway. All right. So when do you use an iHosted service? So on each one of these, I'll talk about when do you use it versus when do you don't. So iHosted service, as I talked about briefly earlier, it's kind of a fundamental building block for some of these other things that we're going to talk about. So you'll implicitly use it when you use some of these other things. And you're using it right now, technically, with Kestrel. If you're using ASP.NET Core, you're using an iHosted service. You just don't know about it. And if you need full control over starting and stopping and won't use the base background service implementation, we'll talk about that here in a little bit. So when do you not use it? Basically, you should be using background service or worker service or Hangfire or something else 95+% of the time, if not like 99% of the time. The other reasons for not using an iHosted service will be the exact same as background service, which we're going to talk about here right now. So I guess before I go on to background service, are there any questions around iHosted service? It's a good time to stop in case anybody's got any questions about it. Free to unmute or drop a question in the chat. Otherwise, I'll keep going. All right, so now we're going to talk about background service. So to keep this cookie analogy going, and I'm going to keep stretching it the whole way. So if you're sick of it, sorry, there's a couple more left. The background service is more of a follow the recipe. So where the iHosted service was like, hey, there's just the raw ingredients. There's no recipe. You figure out how to do it yourself. Background service gives you a pre-prescribed recipe and the cookie jar is included. So background service, exact same as an iHosted service. You host a background job inside of an ASP.NET Core app, where the ASP.NET Core app is your cookie jar. Background service is an abstract class that implements iHosted service. And we'll take a look. We'll actually look at the implementation of background service here in a second. And it exposes an execute async abstract method. So this is where you put your custom code. So like my cache refreshing code, I would drop that logic inside of this execute async method. And background service handles all the starting and stopping for you. So you can't get into that situation that I got into where I accidentally blocked the rest of my application from starting, because background service handles a lot of that for you, because it assumes most of the time you want to kind of fire and forget and not worry about accidentally stopping your entire application from starting. All right, so let's go ahead and do a demo of background service. So if I go over here, I'm just going to crack open the program CS. This is identical to the one from hosted service. So with a background service, you do the same thing where you do add hosted service of T. So some people get tripped up about this of like, well, why isn't it add background service? Well, a background service implements iHosted service, so technically it is a hosted service. So that's why that is, in case you're curious. But then if I go to this guy, the first thing you'll notice is it inherits from background service. And then I've got the exact same code here for my dependencies I'm injecting in the constructor. And then now I've got this execute async method that I have to override. And then the rest of this logic should look very familiar. I'm logging some information saying I'm starting. As long as the app isn't shutting down, go ahead and refresh the cache and then wait every 5 seconds. And then when the job ends, so when you exit this while loop, go ahead and clean some stuff up. So if I go ahead and run this guy, this will look very familiar because you just saw the exact same logic previously. So notice it's saying, hey, I'm starting this background service, and then the web server spins up, and then every 5 seconds, I'm refreshing the cache. So if I come over here and refresh again, and keep refreshing, and refresh again, we keep changing data every 5 seconds, right? So very similar to iHosted service. The difference is you're just dropping your code into this execute async method, right? So then the question becomes, so like I'm somebody who likes to know what's going on under the hood. So let's talk about what's going on under the hood. So first off, again, you register with DI, expose that execute async abstract method, and you can still override start and stop async if you so choose. So if I switch back over here and go override, notice I can override start async and stop async. So if you don't like the implementation of background service, you can go ahead and override it if you so choose. But what's going on here is, if we dive in a little deeper, is this is the implementation of a background service. So if you go ahead and decompile things, you can go ahead and see what's going on under the hood here. So I'm going to move zoom out of the way. Can you all see that when I'm zooming in? I don't know if zoom makes that a little weird when I zoom in. Does it look okay?
Yeah, it looks all right.
Yeah, we can see it.
Okay. Now I'm like swirling around as I zoom in. Okay. So the first thing you'll notice is, well, we've got a field here for holding on to an executing task. We'll talk about that here in a second. And then there's this cancellation token source, and this is really keeping track of when the application's stopping, and we'll talk about that here in a second. Then we've got an abstract method here of execute async. Again, this is what you pass in your custom code. And then inside of start async, they basically are doing the same thing we did in iHosted service, where we just kind of fired and forgot what was going on, but we're not awaiting our execute async method. We're just letting it fire off and then continuing on. And we're passing in this stopping cancellation token source here, passing the token down. We'll talk about why that's important here in a second. And basically, if the task immediately executes, they just return that task that came back. Otherwise, they return a task.completed task. I'm guessing this is like a micro optimization, so they don't actually have to like allocate a task here, but that's just my guess. So inside of stop async, basically, if that line here, this execute async method, this task was never called, it just returns out. Otherwise, it's going to go ahead and single cancellation to the executing method. So it's going to call cancel on that stopping cancellation token source that we passed in above. So this will notify your execute async method that, hey, the application's stopping. And basically this task when any down here, it'll say like, hey, if your task completes sooner, cool. Otherwise, you have basically, this will be 5 seconds for it to complete. And then you have your dispose calling cancel here. So there's really not too much code inside of a background task, and there's really not that much going on, but you can see it's kind of nice because it handles some of those situations for you. So you can't get in that situation that we saw earlier with iHosted service where your entire application doesn't even boot up. So it's abstracting that away from you. So when do we use background services? So if you need some sort of simple background task runner, either as part of your ASP on core application or by its own itself, like you might want to co-locate this with an existing API or application, or you can move it out by itself too. That would be a good example of when to use background service. As you saw earlier, it's got way less gotchas than iHosted service. So it's you can't accidentally prevent your application from booting unless you go ahead and override start async, which at that point you've kind of exited the safe zone, and whatever happens, you've kind of assumed that risk. And it handles those cancellations for you to notify you when the application is gracefully stopping. So like when you're doing a deployment, or, you know, the VM it's running on is shutting down, or whatever the case may be. So another reason to use background service would be if you want some sort of health check endpoint for your background task. So let's say your background service is popping messages off of like an SQS queue or RabbitMQ or Azure Service Bus, whatever the case may be. You might want to have a health check endpoint to like check what's your queue depth to make sure like, hey, I'm consistently popping messages off the stack and I'm not getting too far behind. You can't really do that with worker services, which we'll talk here in a second, but that would be a reason to use a background service over a worker service. So when do you not use a background service? So if you do something like, hey, I'm going to put this background service inside of my existing app or API, that usually works pretty well up to a point, but if it can get unruly and outweigh the convenience of co-locating that stuff with an existing application. So it just kind of depends. Unfortunately, that's the answer to everything in software, is it depends. And you might run into a situation where you have like a noisy neighbor situation, right? Where your background service is generating a lot of CPU that takes away from the CPU that your API needs, right? So it just kind of depends on whether that convenience is worth it. And you could separate that out into its own ASP.NET Core app if you so chose. The other thing you have to worry about is scaling out. So if your code isn't idempotent, you need to either make your code idempotent or not allow scaling out. So let's say you're popping messages off a queue, or you got some sort of cron job that like, hey, I want to wake up every day and go send out emails to my customers of like a notification. Well, if you're scaled out to multiple instances, you got to make sure your code's idempotent, so that way you're not sending the same customer multiple emails, right? So that's just something you got to think about, and make sure that your code's idempotent, or don't force your application not to scale out beyond one instance. Any questions about background service before I get into worker services? Again, feel free to unmute or just drop a message in the chat. Reese says, I want a cookie now. Sorry, I'm in just outside Des Moines, so I'm not sure I'll be able to reach you all the way in Nebraska, I believe you said you were. All right. Cool. So we're going to talk about worker services now. So this is very similar to background services if we continue this cookie analogy, but it's so you follow the recipe, but it's a bring your own cookie jar situation. So you're not, the cookie jar is where you're hosting that code, and you're not hosting it inside of an ASP.NET Core app. So what is a worker service? Basically, in a nutshell, it's just an enhanced .NET console app template. So if you go to the command line and do .NET new worker -O for the directory you want to drop your code into, that will create you a worker service template or project. And what a worker service has is it has a lot of the same things you're probably used to in ASP.NET Core. So it's got things like configuration, it's got dependency injection, it's got logging, it's got a lot of those things wired up for you inside of that iHost, very similar to what you get with an iWeb host in ASP.NET Core. And it registers a worker class as a hosted service. So if you go look at the code that's created for you, it will register this class called worker as a hosted service. But it does not take an opinion on how to host this console app. So there's no cookie jar included. So you can either call this console app from some sort of scheduler, or you could host it in like a Windows service or on Linux using systemd, or all sorts of different ways that you might call this console app. But really, there's nothing hosting your application. You have to figure out how it gets called, because it's just a console app at the end of the day. All right, let's go ahead and look at worker services. So if I close those and declare bankruptcy on those tabs, let's go ahead and look at program.cs here. So you'll get something very similar to this. One of the key lines here is this right here. Again, it looks very similar to what we just saw with background services, where you do services.add hosted service. And by default, it'll create this class called worker, but you can ultimately rename this to whatever you want. This is just the default. If you want to host this inside of Windows service, you can go ahead and get this package here that I've got here in the comments, Microsoft Extensions Hosting Windows Service. Or if you want to host in Systemd on Linux, you can do the same thing and grab that package as well. And then basically it fires up this host, which has like all of your dependency injection, configuration goodness, and then you just call run here. So if we go ahead and dive into a worker, this is the exact same code that we saw in the background service. The only difference here is the class name, or in the background service example, the only difference here is the class name is worker instead of, dashboard cache refresher that I had before. So if you look over here, as we're logging, while it's not stopping, go ahead and refresh the cache, otherwise log, and then wait 5 seconds. So it's like the exact same code other than that worker name. So if I switch this over to worker service, again, this is just a console app, so there's no API with this. So I'm not gonna be able to, fire up a controller without having another project involved. But you can see here, it's the exact same behavior as before, where I'm refreshing it's starting the worker and then I'm refreshing the cache, right? And something you'll notice is I actually had so I'm on Windows currently, and you notice I've got this line here and I didn't bomb. So both of these will no op on the opposite OS. So there's a check inside of here of like, hey, I have to be on Windows in order to run this code, or I have to be on Mac or Linux to run this code. So it's safe to put both of these in here, which can be pretty nice if you're on a blended team environment where some people are running on Windows, some people are on Mac, or whatever the case may be. So that's just something to note. All right. So if you crack open the CS proj, one thing you'll notice is the project SDK is of type worker instead of, you might be used to like web for a web project. And then it's got these different packages here, Microsoft.extensions.hosting, which gives you that iHost. And then I've added the systemd and Windows services as well. So how do you host worker services? Really, that's kind of up to you because it's just a console app at the end of the day. So you could have, Windows scheduled tasks, Kubernetes cron jobs, Azure Logic apps, AWS scheduled tasks, GCP cloud scheduler, something that's going to go ahead and call that console app on whatever cadence you so choose, or make sure that it's running. Alternatively, you could run it as a Windows service or systemd as well, depending on Windows or Linux. And we've already talked about that, those scenarios. So this is kind of nice for situations where you want to run like an out of process background tasks. So maybe it's not tied to your web application, or, it's too noisy. Like, we talked earlier about generating a million PDFs to email like invoices to each one of your customers. This would be an example of you'd be running it out of process away from the rest of your API or application. As well as if you prefer hosting background services outside of a web app. So this is things like, when you're doing a new deployment and swapping new versions of your application in and out with the old ones, you have to deal with things like, on Windows and IIS app pool recycles. Well, that can be a little goofy with running background jobs. So if you want to avoid that goofiness, this would be an example of just running it inside of a console application. As well as if you've got a .NET full framework Windows service today, this is like a logical next generation Windows service to transition if you continue to like that Windows service hosting model. When should you not use worker services? So if you have a team that's used to deploying web applications and you're not used to like running console apps ad hoc, on schedulers or, in Windows services or things like that, you prefer web apps, that would be a reason to prefer like a background service over a worker service. As well as like, if you just have really simple needs, like I've done this plenty of times where I've just had pretty simple needs. So I just put a background service as part of an existing API and everything's perfectly fine. So if you don't really have like, hey, it's not worth the extra headache of managing like another deployment, that would be an example of why you'd want to use a background service instead of a worker service. And that's kind of why I say, like, when somebody says they're using a background service, that probably means they're hosting it in ASP.NET Core, because otherwise, if they're hosting it in a console app, they would probably say worker service, because that's ultimately what it is. So another reason, we kind of touched on this earlier. So if you want some sort of health check endpoint to like check to see like, hey, is my is my background service doing okay? You can't really do that with a console app. So that would be an example of you'd probably want to host that on a background service inside of ASP.NET Core. All right. Next, we're going to talk about Hangfire. But before I do that, anybody want to talk about hosted services? As an aside, if you throw an exception, if you have like an unhandled exception inside of a worker service, it will tear down your application. So something to note as well. Any questions? Going once, twice. All right. So the final cookie analogy we have here is buying pre-packaged cookies with Hangfire. So Hangfire is library that kind of comes with a lot of features out of the box. So it's like going to the grocery store, buying those prepackaged cookies. You don't really care how it's made. You don't really have much control. You just wanted to grab some cookies. So Hangfire is a full-featured open source library for running jobs inside of ASP.NET Core. It is free for commercial use, but if you want some sort of support, it ranges from $500 a year to $4,500 a year, depending on what features you want or what service level agreements that you want. So it's pretty reasonable. Hangfire out of the box comes with a UI for monitoring and history. So, and it supports cron jobs as well as ad hoc running of jobs. And we'll take a look at both of those here in a second. And it allows for things called continuations. So if you're familiar with that concept with, async await, it's the exact same concept where let's say you want task A to run before task B, before task C. You can set up continuations in Hangfire and it will manage and orchestrate that workflow for you. Comes with automatic retries out of the box. So by default, you get 10 retries and it'll do an exponential backoff after each retry. And we'll take a look at that here in a second. And it supports concurrency limiting. So we talked earlier about, preventing scale out to not have the same job running on multiple instances. Hangfire supports that out of the box. And it persists the job state to a database. So if the application dies for some reason, it's going to keep track of the state of that job and then rerun it when it picks back up. Now, it doesn't pick it back up like in the middle of the method. Basically, it'll restart the job again from the beginning. So that's just something to note. So you can kind of think of Hangfire like a message queue because it's got, but with some additional features like a UI. It's got like a dead letter queue, which we'll look at in a second, and things like that. You can basically think of it like a message queue with like things like cron jobs and stuff like that. All right, enough talking about it. Let's go ahead and look at a live demo. So I'm going to go over here to the Hangfire project. I'm going to crack open the CS proj first so you can see what this looks like. Basically, I've got three projects here, three packages here, an ASP.NET Core package. So Hangfire runs on legacy ASP.NET, like the non-core version as well. So this package will wire it up with ASP.NET Core. It's just its core package. And then I'm persisting it to SQL Server. So I've got a local SQL Server Docker container running. And so it's persisting that state to that SQL Server. We'll take a look at that here in a second. So if I crack open the program.cs now and take a look at what's going on here, really the thing I want you to focus on is, to start with, is line 12. So you can see it says services.add Hangfire, and then there's a bunch of configuration options. These are really just some options out of the box. I'm not going to get into the nitty-gritty details of these, but you can see right here, I'm saying, hey, go ahead and use SQL Server. There's my connection string that's coming from configuration. And then here's some options for SQL Server as well. None of these are super, we're not going to dive into all these different options, but I just want to show you the main point here is you do add Hangfire and then you can configure it to your persistence that you so choose. It also supports like Postgres, Redis, and a few others as well. So you need to register the Hangfire server, and this is kind of like a worker that's going to do the actual work and execute your jobs for you. And then this map Hangfire dashboard gives me my UI. And then I can register some cron jobs here. And so there's two cron jobs. This is a simple one that's just like an inline method where I'm just doing a console write line every minute. And so it's just executing this console write line every single minute. And so it's adding this job on startup. And then I've also got, I'm calling this job service and this job with name async method, and I'm calling that every minute as well. So if we dive into that guy, there's this job display name attribute. So you can give a job a custom name. So in my case, I'm giving it this name called custom job name, because otherwise it doesn't really know what to call your job. And so by default, it'll just pick the first method that you've got in your job. And so this job here is going to get called console write line, and this custom one will get called custom job name. So this waits 5 seconds and then goes ahead and calls the console write line. Okay, let's go ahead. That's enough talking. Let's go ahead and run this so we can see what that looks like. So first thing you'll notice is you're going to get this UI here where it's saying, hey, it's showing you a real-time graph, showing you history as well, and you can take a look at these. If I go to the jobs tab here, I can see like, hey, what's scheduled, what's processing, what's succeeded, all that kind of stuff. And if I go to recurring jobs here, this is where I register my cron. This is where those cron jobs that I registered show up. So you can see like, hey, I'm about to execute this in a few seconds. And I can even trigger these on an ad hoc basis. So I'm going to select both of those and trigger both of those now. But you notice like this is my inline one where it says console write line, and this is my custom job. So I can trigger those a few times, or I can even delete the cron jobs if I so choose. So if you go to this processing tab, you notice my custom job name is still processing here. One thing to note is this page doesn't always auto refresh. Usually the badges auto refresh, but this page itself doesn't auto refresh. You can see all my jobs are finished. And if I go to the succeeded tab, you notice I've got 3 jobs or 3 completed jobs for each one that I registered. So I've got 6 total. And it shows you like the current total duration. So basically this overhead is not the overhead of console write line. Like a console write line does not take 79 milliseconds, but this is basically the total overhead of running your job plus saving this job to the database and everything that Hangfire does. It took 5 seconds and change. You can go in here and dive in and see like some information about what happened. Go and look at whatever information that you want. That's all good and everything, but like what happens if you don't have a cron job? Like you want to execute something ad hoc. So if I go to this Hangfire controller, so it's a normal controller as you would expect, but I'm injecting this iBackground job client, and this is coming from Hangfire. Now, normally I'd probably wrap this in another class and isolate my Hangfire logic, but for demo purposes, I'm just injecting in the iBackground job client directly. And then I've got this HP get method, and I call inQ on the background job client, and then I provide it this method that I'm going to call here. So you can see it's saying hello from the controller is what I'm passing down to this method down here. So what's interesting about this is look at the job display name. I've got this curly 0 here, and this is very similar to string.format where it's basically going to take the parameters and replace those values. So in Hangfire, in that Hangfire UI we just looked at, it's going to say triggered from controller with hello from the controller. So this, you can pass some like extra metadata of what was called with your method, or like whatever metadata that you want, and have it show up in your job in a dynamic fashion. So you don't have to know that ahead of time. Basically, again, all this does is does the task.delay, waits for 5 seconds, and then writes out the value that I had here. So if I go over here, and I'm just going to go ahead and call the API Hangfire method, and that triggered that job. So you can see here it says triggered from controller with hello from the controller. And after 5 seconds, you notice it ends up in the succeeded jobs. So this would be an example of where you want to, like, let's say, that submit invoices or create invoices button that we talked about earlier. This is where you might create a job maybe per invoice, or maybe you just create one job that then spawns the rest of the action to happen. So that's how you create jobs dynamically and not just through cron jobs. Which is kind of nice. One thing I didn't call out here too is you can have, you notice I've got one server here, so you can have multiple servers registered to a single Hangfire UI. So if you need more scale and more processing power, you can register multiple servers to the same Hangfire UI and kind of co-locate that, not have separate instances that you kind of have to manage yourself and group together yourself. But let's say I'm going to go ahead and throw an exception here. So I'm going to say, I'm going to go ahead and stop the application from running because I don't want to do any hot reload business. So I'm going to go ahead and throw an exception and say the Cubs are better than the White Sox. I could spell. And I'll make some people in this room upset because I am a Cubs fan. Those who are White Sox fans, I'm sorry. Those of you who don't care about sports ball, don't worry about it. But I'm now throwing an exception here. So let me go ahead and run this application and let's trigger another job and see what happens. So I went ahead and triggered that. And you notice it popped into this retry section here. So it's saying, hey, retry 1 of 10, attempt 1 of 10, and it gives you some information about the exception. I can even dive in here and see the stack trace of what it is that happened. So I can trace back like, oh, it happened on line 28 here, right? So I can go ahead and say, you know what, it's a dead letter queue. I'm going to go ahead and requeue this. Of course, this is going to keep throwing an exception. And one thing I want you to note is when it's going to retry again. So you notice it's retrying in a minute. If I requeue this again, it's still a minute. Requeue this again. Now it's 3 minutes. So again, as I mentioned briefly earlier, it's going to do an exponential back off and keep retrying and keep adding more and more time to give it time to recover. So now it's 5 minutes. All right, we're on 6 of 10, 13 minutes. I think it gets up to like 2 hours when we get to the end. 23 minutes, 41 minutes. We're on 9 of 10 in an hour, and now 2 hours. So what's going to happen when I in-queue this after attempt number 10? Basically, it's going to go to a permanent dead letter queue and not do any retries and go to this failed section. So at this point, I can take some action on this. So just like a normal message queue where when you get some messages in a dead letter queue, you got to take some manual action, right? There's really no, not an automated way of handling those messages once it drops into like the permanent dead letter queue where it's like, okay, I've retried enough and I don't know what to do with this. So I can requeue this. Like, let's say I'm like, oh, I'm not handling some situation here. I want to delete this code and go ahead and requeue it. I can just demo that here real quick. So I'm going to go ahead and remove this, and I don't trust hot reloading, so I'm not going to kick the apply changes button. And I'm going to go ahead and re-kick this off. Notice, even though my server tore down and everything, it's still got this in the failed messages because, again, it's persisting this to SQL Server. So if I requeue this, this should succeed. You notice it's running. It's going to wait the 5 seconds. And eventually, so this is an example of the badge updated here. So it says 0, but this UI does not update. So if I refresh that, now it's done processing. And if you look, here's that message that ended up processing successfully. So this job that processed successfully, number 16 here. You can see it's even taken into account like all the other times that it ran and how long it took to actually get to the successful state. So that was just a quick tour over Hangfire showing the different functionality that it gets you out of the box as opposed to like background service where you don't get, or worker services where you don't get that UI or any of that retry functionality. So how does Hangfire work? Basically, it takes that method call that you pass to it in that cron job or the in-queue method. So basically this right here. So it's going to take that and serialize it to the database. So it's going to say, hey, call this method with these parameters, right? So if you change your method names, it's not going to know what to do because it can't find that method. So that's something to keep in mind, be mindful of. Is if you've got something in like your dead letter queue and you try and rename your method and try and re-enqueue that job, it's not going to be able to find it. So just potential gotcha there. And then it creates a background job based on all that information, saves that jobs to whatever persistent storage. Again, I'm using SQL Server, but it could be Postgres or Redis or whatever the case may be. And then it'll start that background job if you did like an enqueue method, or it'll wait until it fires off your cron job, for instance. So when should you use Hangfire? So Hangfire does have a dependency on ASP.NET Core, at least in the UI side of things. And so if you need those features that Hangfire offers, you're going to be in ASP.NET Core land. So if you don't want to write some of that plumbing code yourself, that would be another reason to use Hangfire, like with the retries and like the UI and all those sorts of features. Like if you don't want to create all that yourself, that would be a reason to go to NuGet and install Hangfire. As well as if you're okay with relying on a third-party library. So this is a third-party library, not maintained by Microsoft. So some people get a little squeamish about that. So that would be another reason to use Hangfire, is if you're okay with that. As an aside, so there is a company behind Hangfire, as you might have guessed with the fact that they offered paid support. That company was based in Russia, which in light of recent news with the war going on with Ukraine, he has since relocated to Estonia and moved his company out of Russia. So if that's a concern for you, he's moved out of Russia into Estonia. And so he's no longer based in Russia. So I know that might make some people uneasy as well, but he's since moved out of Russia. So when you not use Hangfire, if you don't want to host jobs in ASP.NET Core, because again, you're hosting, you have a dependency on ASP.NET Core. In this case, you're going to be hosting in a web fashion. If another reason not to use Hangfire would be is if you just have basic needs, like in my dashboard cache refresher, I probably didn't need the UI. I didn't need all those fancy features. I could just use a background service and not have something super heavy handed. And if you don't want to rely on a third-party library, so iHosted service, background service, and worker service are all things provided out of the box by Microsoft, whereas Hangfire is a third-party library. And if you're one of those people who wants a lot more control over what happens, that would be a reason not to use Hangfire as well, because you don't really get a ton of control over how it does its thing. Now you can configure lots of things. So let's say you want to retry 5 times or 20 times instead of the default 10. You can absolutely do that. So they give you a lot of knobs to turn for configuring things how you want. But if you want full control over what happens, that's really not the case with Hangfire. You're delegating some of this work off to them. All right. Those are the 4 main options that are cloud agnostic. Anybody have questions about Hangfire or any one of these other options? Before I dive into the cloud options. Going once. How long have you been using Hangfire? I think I first used Hangfire in like 2017 or 2018. So a few years now. I don't use it on everything. I've just used it in projects in the past. Cool.
Scott,
I saw David on mute. Go for it.
For just in
I
general,
can't hear you. I don't know if it's me or
you can't hear me. Can other folks hear me?
I can hear you, Scott.
Somebody else say something? Maybe it's me.
Yeah, I think it might be you.
Uh-oh.
All right.
Oh.
Hold on, it might be me.
We can type in the chat instead.
There we go. I turned off my headset. I don't know what's going on with my headset and switched my laptop speakers. Go for it.
So with the periodic rates that you're having these different events occur, are these going to be susceptible to changes in the system clock?
So the periodic,
and that's kind of in general across all these different options. Are they all going to be, as far as their periodic rate that they're going to be running at?
Yep, that's a good question. So the first 3 examples that I had where I was just switch back to code here. So if I could go look at like worker service, for instance, I'm just waiting 5 seconds. So I'm not saying like, hey, go pick up at this certain time, right? So like if daylight savings time rolls over in the middle of the night, it's still going to wait 5 seconds. So in that case, I wouldn't be. Now, if you're saying like, hey, so there's a whole bunch of things you can do with like Hangfire where you can say like, hey, run this on like the first, so it supports any cron expression. So you can basically say like, hey, run this on the first Tuesday of the month at 9 p.m. or whatever the case may be. So like anything you can imagine in cron, it can do, and it's going to handle all those situations for you. So it shouldn't, the clock changing, well, I guess I take that back. If you change the clock, for, like if you go, like if I go over here and just right click, adjust my time, yes, it's reading off of that. So in that case, it would. from Hangfire's perspective. But as long as you're not doing that, you should be good to go. Like just, it should be able to handle daylight savings time and all those kinds of scenarios for you.
Yeah, I was thinking of the cases where your clock gets it, it does its periodic updating to the atomic clock or whatever, and it might roll back a few seconds. So you may not have 5-second delay, you may have 8 or 9, and maybe that's okay, but maybe it's not. So
yep.
I didn't know if there was any magic going on behind the scenes on any of these that might help account for that.
On the so like this one should be safe. As far as Hangfire goes, I'm not aware, I've never run into anything that's caused that, something like that. But
okay.
Yeah, it also might be like ideally having your code like be semi-resilient, so it doesn't have to start like precisely at 9 p.m. like in 0 seconds or something like that. That it can handle like a delay, because like your server might be down or whatever the case may be. So
sure, absolutely. Cool.
Yep.
Thank you.
Yep. It's weird that my headset just died. It was working earlier, but I guess I was talking too long. All right. So if there's no other questions, let's talk about quickly the cloud options. So I'm not going to do a deep dive of these, but I'm just going to call out some for you to look at later. So if you want to run things like cron jobs and things like that, you can do that with like Azure Function, set up triggers based on those to fire off your Azure Function. You can do Azure Web Jobs as well. In AWS, Lambda is very similar. You can set up triggers to like fire off things as well. If you're in GCP, you can use a combination of like GCP Cloud Scheduler and Cloud Functions to fire off things as well, like on cron jobs. I didn't get into any of these because I wanted to be cloud agnostic. But if you're in one of those clouds and you would rather use like their service, those would be ones to check out. And there's a few different other options in those cloud providers as well, because AWS has tons of new services coming out all the time. All right, so what I hope you got out of this was awareness for all the different options available to you when you need to run something in the background, and just more information so you can make the best decision and what makes sense for your scenario, because all of these have different trade-offs and you just kind of have to figure out which trade-off you're willing to accept. So I do have some resources here. I'll leave this up for a second if you want to take a look at this or screenshot this or whatever. But the official Microsoft documentation is that first one. It kind of talks about iHosted service versus background services. That second bullet point is Hangfire's official site, so hangfire.io. The third bullet point, if your company has Pluralsight, Steve Gordon spends like 2 or 3 hours going into hosted services versus worker services. And obviously, with it being 2 or 3 hours, he can dive a lot deeper than I got into here in just about an hour. But I also left this slide deck pretty detailed intentionally, so that way you can download the slide deck. I know David linked to it in the chat. You can download the slide deck and kind of get look at it later and get the gist of what it is that I said. So with that, any questions?
Hey, Scott.
Hey.
Great presentation. Thank you. I was just wondering, in the production environment, you always have to worry about performance, throughput, and things like that. What has been your popular solution? I know in my organization, we're using Kubernetes cluster, we're using Kafka, to queue up the events and stuff like that, and,
sure.
and some sort of a scheduler. And obviously then, your cluster can scale up and down. But in your experience, it seems like you guys do a lot of this kind of stuff. So what is your favorite solution from production ready standpoint? Yeah.
Sure.
Thank you.
Yeah, you probably heard this answer before. It depends. I do like Hangfire for situations where like I want to visualize the UI. Essentially, Hangfire is like a message queue. So if you've got like AWS SQS or Azure Service Bus, or if you're using Kafka in that way, it's very similar to that. It just kind of gives you a UI. And so it's kind of nice when I don't like, maybe I don't want to pay for, SQS and Service Bus are pretty cheap, but like maybe I don't want to pay for that and I just want to like have it as part of my normal application. Because there's kind of like a varying level of like, if you've got simple needs, like say you've got like an intranet type application where your users are like your typical 8 to 5 users, that's a lot different scenario than, if you're like a retail operation that's 24/7, all those kinds of things. So depending on the scenario that I'm in, and like what performance characteristics I expect, that would lead me to like go one way or another. So if I'm in like the retail scenario, I probably wouldn't use things like I hosted service directly or background service and have it part of like the API. I would probably separate that out because it's something more important. As far as Hangfire goes, I mean, I've used it in situations where, we needed to process, I think it was like 200,000 messages in an hour, and it handled it just fine. I think that's the most I've done is handling 200,000 messages. So that's the most I can speak of on the Hangfire side of things, but it just really kind of depends on your scenario because there's like a lot of different reasons why you might want a background job or background service.
Okay, interesting.
So
you guys are using some kind of commercial license of that, right? Or
I've done both. It just kind of depends on like, for instance, like if I'm at a client, whether or not they're willing to pay for it. It technically like everything I just showed you is available in the free version. It's just like, hey, if something goes wrong, do you want service support and things like that? Some clients, it's a no-brainer. Like, yeah, I'll just pay the money. Other clients are a little bit more hesitant, I guess. So it just kind of depends on the scenario. But like one situation I was in, there was an API. The data like hardly ever changed. So it was products that this company sold, and they sold products that really never changed. Like they came out with one new product a year, and they had a particular API that listed all their products, and it was extremely slow. So we're talking like 20-30 seconds to hit this API, and it was something that was a third party that we couldn't control. And so in that case, what we did was we just set up a background service that I think it was like every hour, it just hit that API and cache the results. And literally that data never changed. That data never changed except for once a year. So that was an example where we just used a background service. Super simple, didn't really matter. But would I use that in all situations? No. It just kind of depends on your scenario.
Okay, great. Appreciate it. Thank you again.
Yep. Any other questions? I don't see anything in the chat. And if you have questions after this, feel free to reach out to me. There's my email out there, or you can hit me up on Twitter. I'm not trying to upsell you or charge you. If it's not obvious, I like talking about this stuff. So if you have questions or curious about a certain scenario, just let me know.